Hello, boys and girls. Hello, my sailors. I hope you guys are doing well. Sorry, I had to cancel the class yesterday. I had to leave in between because I was facing some net issues. No worries, I'm back here. Today, let's study about gold number. And yes, the session is packed with a lot many information. So be there till the very end. All right, let's start. My name is Harsh Maheshwari. I'm your captain. My students call me captain. If you're new here, you can call me captain. Otherwise, you can call me sir as well. If you're slightly more daring, do call me captain. And yes, I am from NIT Warangal, and I believe in one thing that jo karo, maze se karo. All right. Moving on, boys and girls. This is our daily schedule. Please make sure you take a screenshot shot so you would be understanding when your favorite teacher is coming live and you can attend the lecture. All right. Moving on. And yes, there's also one more way to know that your favorite teacher is online and you are teaching, you have to attend the lecture. You can subscribe to our channel, and also one more thing you can do, you can hit the bell icon so you will be notified when your favorite teacher is coming live. All right. And your favorite teacher is, who is he? All right. Moving on. Boys and girls, if you are weak in a particular topic, let's say in physics, let's say in chemistry, or in maths, you can buy our special micro courses. They will help you to sharpen your skill in a particular topic you are weak at. Okay? So make sure you avail this, and they are available at a very very low price, that is just 1 rupee. Okay? So make sure you take this opportunity and buy few courses for yourself. And if you are weak at that any particular topic, please do make sure you buy it. And link to it is given in the description box. All right. So I'm starting now. The first thing, what will be we will be learning. What would be the learning objective today? It will be gold number. We will finish gold number today, boys and girls. And before gold number, I have to give you few more informations. So I'll give you that. Few more information I have to give. So I'm giving that. First thing I have to start is coagulation or flocculation. Beta, we have done precipitation, we have done peptization, you remember? It is just reverse of peptization. In peptization, I told you your bigger molecule, we will break it down to smaller particle. Here what we are doing, we are converting a small particle, our colloid. Colloid is nothing but, colloid is nothing but a small particle. We are converting our small particles into a larger particle. We are converting it into PPT. That is your coagulation or flocculation. Understand? We are going to convert your colloid into PPT. Now, how we are going to do that? Boys and girls, we are going to use electrolytes. We are going to add electrolytes. For example, I have taken in this particular case, I have taken a positive colloid. I have taken a positive colloid. So I will add an electrolyte. Electrolyte contains positive as well as negative part. Now, since the colloid was positive, I will take the negative part of the electrolyte, that is anion, right? It will come and sit, or it will start reacting with the colloid, neutralizing it. As a result, it will convert into PPT. So higher the charge, pay attention. I am going to give you an important thing, one more information. So what is coagulation? What you are doing, you're neutralizing, you are basically neutralizing your colloid to convert into PPT. And how you are doing it? By adding an electrolyte. And if I would have taken a negative colloid, then the positive part of the colloid will start neutralizing it, and you will end up getting a PPT, right? The colloid will settle down. The particles which were moving here and there, they will settle down at the very bottom. That's what's going to happen. That is what's going to happen. Now, similarly, pay attention to a very important point. Higher the charge, boys and girls, higher the charge on this electrolyte. For example, let's see this case. I had a positive colloid. I am adding an electrolyte. The negative part of the colloid was actually responsible for the neutralization process. Higher the negative charge, if I would have these options, higher the negative charge or higher the charge on this electrolyte, more easily you can do the neutralization process, more easily you can form PPT, right? So if I will ask you what is which anion is preferred, you will say higher the charge, easier for us to precipitate our colloid to make sure it neutralizes, right? This is nothing but Hardy-Schulze rule. So I'll explain that in a second. So right now you can take this screenshot of coagulation. I have just explained what is coagulation. When you convert your small particles into PPT, you convert your colloidal solution into PPT. How you have done it? By adding electrolyte. This process is called as coagulation. And similarly, if I will use an electrolyte, I am using electrolyte, right? If I will use higher charged electrolyte, if I will use higher charged electrolyte, it is easier for me to do the neutralization process. That's what Hardy-Schulze rule is. Just remember, I told you B minus, B2 minus, B3 minus. So B3 minus will do more coagulation, more precipitation. The neutralization would be very easy. So this is stated by Hardy-Schulze rule. Let's give you an example. Suppose I have a cation, and we are adding, suppose we are adding cation in a negative colloid solution. So I have a negative colloid solution. I'm adding, first of all, I will add an electrolyte. Electrolyte contains positive as well as negative part. Since I have mentioned I am taking a negative colloid, so what will happen? Positive part will take part now. Participation will be done by positive colloid. Now higher the charge on this positive colloid, more would be the neutralization. Easily you can form PPT. This higher charge is called as coagulation power. So coagulation power depends upon the charge on the electrolyte. Higher the charge, higher easily it can do the neutralization process. Similarly, for example, I have given a beautiful example. If I have taken a negative salt, so you have to add electrolyte, right? Add electrolyte. Now the question is, which part of the electrolyte will react? Now the negative part will react, right? The negative part. And higher the negative charge, I have given some example, Cl minus sulfate ion, phosphate ion, take a phosphate ion. So what you will do? You have to take the last one. The coagulation power is more here. That's what this rule is all about. Higher the coagulation power, and it depends upon the charge. So higher the coagulation power, more will be the neutralization. Easily you can convert your colloid into PPT. There is also a thing called coagulation value, right? It is inversely proportional to coagulation power, right? For example, what is coagulation value? Number of millimoles of electrolyte that must be added in a solution. As a result, precipitation will happen. So if you have to add a very little amount of electrolyte, you will say coagulation value is less, but the power of coagulation is very, very high. I hope the point is very, very clear. What I am adding here, what I am saying here, you're adding an electrolyte. If less amount of electrolyte is converting your colloid into PPT, you will say coagulation value is less. Coagulation value is less, but the power is very high because little amount is sufficient to precipitate your colloid, right? So coagulation power is inversely proportional to coagulation. Let me write it here. Coagulation value. So if value is less, power is high. So based on this, I have given a question to you guys. Pay attention. So two electrolytes are there, A and B. Both are having these values. So which is having more coagulation power? Answer is A. Means I am adding only, check this definition out. I am adding only 10 milliliter, right? I'm adding this definition. Check this out. I should say millimoles. I'm sorry. I'm only adding 10 millimoles of the electrolyte in the solution, and everything happened. Your colloid converted into PPT. But in the case of B, I had to add 20 millimoles. Then precipitation happened. So where the value is less, power is more. So the answer is A. I hope it is clear. This definition makes it very, very easy. How many millimoles of the electrolyte you have to add in 1 liter solution, of course, of the particular colloidal solution? How many electrolytes you are adding into it? How many millimoles of it? That is called as coagulation value. If small amount is added, means power is more, right? So that was the question, or in short, you can remember coagulation power is inversely proportional to coagulation value. Similarly, boys and girls, very important thing I'll talk about today. I think you might have seen this example, right? What happens, boys and girls? Your lyophobic salts are very, 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 very difficult to prepare. I have discussed this in the previous session, in the previous class. These are very difficult to prepare, and if you also prepare, their shelf life is very bad. They will precipitate, and they will be, they will become suspension. They will precipitate at the bottom. To increase their shelf life, what you do, you add lyophilic salt. Lyophobic are very difficult to prepare, and their shelf lives are very bad. Terrible it is. So what you do, you add some lyophilic sol also in your lyophobic solution. So what happens if I have a lyophobic sol? For example, let's say this is lyophobic. It is very difficult to prepare. What I will do, somehow I have prepared to increase its shelf life. What I will do, I'll add some lyophilic. I add some lyophilic sol. What it does, it protects, it forms a layer over the, it forms the layer over the lyophobic soil. As a result, it increases its shelf life. What I am doing here, I'm trying to increase the shelf life of a lyophobic soil by the help of lyophilic soil. It is forming a protective layer. It is forming a protective layer over the surface of lyophobic soil. As a result, shelf life increases. Now, where is this example happening? Let me tell you. I am pretty sure everyone might have seen it. Check this out. You know your pen refill. This is called as roller. It has a very small roller. It keeps on moving. That's how you are able to write. Your ink, the pen refill is basically having a lot many different color in different colors. You are getting your pen refill, right? What is happening? You are using metal sol there. It is a colloidal solution, and basically metals are taken. Different metals have different colors, hence you created it, right? So basically this is happening in a ball pen. All this is happening in a ball pen. So what you do, you have a refill. In this refill you basically have a simple sol, colloidal sol of metal, and they are lyophobic in nature. So what happens, you might have noticed it, these pens stop working after a certain time, or sometimes you have to just yank it up. You have to do like this. Have you done it? And it stops working. What happens? Coagulation happens at the bottom, at the very bottom, at the very bottom. Precipitation happens. What happens? Coagulation happens because this lyophobic sol is unstable, so it will precipitate. It will basically precipitate, and this working of pen will stop. So what you do, you shake it off, you yank it, or you start rubbing that particular refill or the pen. What happens? This bubbles or this PPT form again get disrupted, and you start working with it, right? That's what you do. But if you have bought a slightly expensive pen, what happens there? You might have seen this particular end in your refill. Again, I'm talking about a ball pen, right? Check this out next time, है So what will happen? Basically, you are doing protection. What you have done on your lyophobic sol, you have added some lyophilic sol. It will do the protection, and this is quite evident there. Now, what will happen? This precipitation will not happen. As a result, this will never precipitate, and you are getting a smooth flow, right? Are you understanding? Sabko samajh aa raha hai? You know what kind of pen you guys are using. So this category belongs to that. If it is not forming any precipitate, you will keep on writing, and you understand because you have bought an expensive pen and it works properly. I hope it is clear. So this is a phenomenon. This is our best example of your protection of lyophilic, or I should say protection of lyophobic soil by the help of lyophilic soil. How awesome is that? All right. Last but not least, gold number. Boys and girls, gold number, very, very important. What happens in gold number? Pay full attention. Let us say I have taken 10 ml of gold sol. In this gold sol, beta, if I will add 1 ml of NaCl, right? If I will add 1 ml of NaCl, 10% NaCl, it will start precipitating. Gold sol is a negative sol. I have told many times. It is a colloidal solution. It is a negative sol. If I add NaCl, it will start precipitating. 1 ml of NaCl, it will start precipitating. How many ml? I'm so sorry. How many ml of your lyophilic here? What you will add? You will add lyo. Let me just. How many gram or milligram, how many milligram of lyophilic sol you must add? How many milligrams of lyophilic sol you must add so that the protection of the gold sol can happen? That particular number is called as, whatever the gram you are adding, that particular number is called as gold sol. I repeat the process. You are gold, you are taking 10 ml of gold. If you will add 10% NaCl of 1 ml, if you add 1 ml of 10% NaCl in this particular gold, it will start precipitating. It will start precipitating. To stop this precipitation, you do the protection of gold. How much milligram of lyophilic sol you have to add so that the protection does not happen, so that the precipitation does not happen, is called as gold number, right? So what is gold number? It is the number of milligrams of lyophilic colloid added in 10 ml of solution to stop the coagulation if 1 ml of 10% NaCl is added. Understood? So you are basically trying to stop the coagulation by adding the lyophilic soil. It is acting as a protective colloid. It is acting as a protective colloid, right? And it will help in the protection of your gold soil. Understood? Clear? Whatever the amount is there, for example, I say I have added the gold number. The gold number is 2. It means 2 milligram of your lyophilic salt has been added in 10 ml. It means 2 milligram of your protective colloid has been added in 10 ml of gold salt. I hope everyone is understanding. So we have a formula for it. I can give you any particular example. I can ask calculate what is the gold number. I will also show you. You need not to learn this also. Okay, how many milligrams of protective colloid you have to add divided by volume of solution in milliliter into 10. Why I have done into 10? Because gold number is defined per 10 ml of solution. Check this out. The definition for how many ml? 10 ml of solution, right? That's why you have done 10. I'll show you in 2 minutes. You need not to use this formula as well. Check this out. Another thing. Here also we have one more thing. If you're doing protection by the help of a lyophilic salt, if the protection power is very high, gold number value would be very less. So for example, I have given lyophilic colloid. This is doing your protection, right? If the gold number value is very less, means protection power of the lyophilic soil you have added is very high. So gold number 10, gold number 20, which is having more protecting power? Answer is option A. What is that? Because when you will see gold number 10, it means 10 milligram of your protective of lyophilic salt has been added in 10 ml of gold salt to protect it, right? When you have gold number as 20, means you have to add 20 milligram of lyophilic salt so that the protection happens. So where you had to add less amount of lyophilic salt or your protective salt, it is in the case of 1. Okay? So that A is your answer. I hope it is clear. Protection power is again inversely proportional to the gold number. Wherever numbers are there, lower numbers, higher will be the protection power. Just remember that. Alright, one question is there. If 10 milligram, this is the last question on gold number and we'll end the class with that. If 20 milligram of colloid is added in 100 ml gold solution to stop the coagulation, find gold number. Very simple. Dekho. So you are saying 20 milligram of the colloid you have to add to stop the precipitation, and you had to add 20 milligrams for 100 ml of gold salt. Correct? So what is gold number? Gold number is always defined for 10 ml. So can you tell me how much how much of that particular colloid you have to add? Just do the cross multiplication. Because gold number is always defined for 10 ml, right? So 20 milligram of colloid was taken when 100 ml of gold salt was given to you. 20 milligram was doing the job, it was protecting it. For 10 ml, how much it would be? Just do the cross multiplication, get the answer. So let us say it is x into 100 is equal to 200. X will come as 2 milligram, or x should be we can say so gold number is nothing but 2. You can also do it by the formula. How many milligrams of the colloid you have to add? 20 divided by how much? What was the volume of the gold solution? 200. since it is defined for always, always it is defined for 20 milligram. ठीक है, 100, यहाँ 100 है, I'm so sorry, this is 100. Since it is always defined for 10 ml, that's why I multiplied here 10. What will be your answer? 2 milligram, right? So your direct, see, no milligram. This is our gold number. So either you can go for the formula, or you can go for this, right? Both are going to give you the same answer. I hope it is clear. So gold number I have talked about. Let us also discuss one more thing. The real life examples of your surface chemistry. I tell you why. One example. I am pretty sure everyone knows that I have discussed that blood is a negative soil. Have you seen aftershave lotions, right? After-shaving lotions are there, right? And sometimes if you get a cut when you might have seen your parents, right? Your father, you might have seen. If you get a cut on your face while doing the shaving, right? Shaving process is done. They have this alum, right? They apply it. It's just nothing but a aftershave lotion. Alum is actually, basically a positive colloid. So blood is negative, alum is positive. If you rub it there, it will become neutral, and the blood which is coming out of that cut stops there, right? So basically you are doing their neutralization process. Blood is a negative soil, you're applying alum there, right? White, but it gives a cooling effect. Do not try it, but it gives a cooling effect. And when you do it, what happens? It is positive, blood is negative, neutralization will happen. Have you seen islands, right? I'm pretty sure you have seen many movies, and some of you might have been to one, right? So what happens there in island, actually, let me just explain. In islands, what happens, how it is formed? Rivers are actually, sometimes rivers are falling into the sea. Rivers have clay in it. Clay is a negative soil. When negative soil enters into the how do I put it? NaCl. Your sea water is full of NaCl electrolyte, right? So what happens? Clay is negative, Na plus is positive. Neutralization happens, and this neutralization keeps on forming, keeps on increasing, and as a result, a heap of land is created, which we call as delta or island, right? Delta or island is created just like that. Whenever a river enters a particular enters into sea. C has NaCl. NaCl is of positive charge, and your clay is negative charge. This is going to do a neutralization process, and you will end up with a delta or an island. Okay, this is very good, a beautiful example on surface chemistry. All right, so boys and girls, if you are there, on our app, very good. If you are not there, please download the app. We are conducting some amazing quizzes, and you can also get a chance to win some Paytm cash, 5,000 rupees, 10,000 rupees. The award is huge. So go there, check it out, give some tests, and if you're lucky, you win some, right? All right, moving on. Again, I will tell you, I can't focus enough, I can't stress enough on whatever the stress I'm giving here is all less. Please make sure you check out these micro courses. The price is very low, and if you are weak at a particular topic, make sure you be good now. Okay, so avail this micro course and be awesome. And yes, my playlist is out there. It is again in the description box. If you are coming here for the very first time, all the lectures you can learn. I have done many lectures. The playlist is down there in the description box. And similarly, boys and girls, please make sure you subscribe to our Vedantu JEE channel on Telegram, because we are telling you the daily schedule. We are giving you assignments. We are letting you know when the teachers are coming live. So make sure you go check it out. And yes, if you have loved the session, please make sure you like it, share it, and subscribe to our channel. Thank you so much. That's it from me today. See you next time. Bye bye.